back this truck up. Here's the objectives. Okay, here we go. Now, what I was saying earlier about patterns, when you're doing the sum identity for sine, the pattern is sine, cosine, cosine, sine. Sine, cosine, cosine, sine. And it's a similar pattern for when you're taking the difference of two angles. The sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. Right? That's a pretty useful skill to have.
It's just a fish and half a butterfly.
Yeah.
I just feel stupid.
The two sum and difference identities for cosine. So we have cosine of alpha plus beta. This has a different pattern. It's cosine alpha cosine beta minus sine alpha sine beta. Not really.
Okay.
Just grouping them together. So the pattern for cosine is cosine, cosine, and then sine, sine. And the other thing that's hard to remember for students is the sign switches. If you're doing the sum of two angles for cosine, then in the identity there's a minus. It's cosine, cosine minus sine, sine. So the sign switches. But if you're doing the sum or difference of sine functions, if there's a plus, if you're taking the sum of two angles, then you're taking the sum of these two expressions. So if we're doing the cosine of alpha minus beta, it's going to be cosine alpha cosine beta plus sine alpha sine beta. Those are the two identities for the cosine. Now for tangents. These also have a pattern that you want to try to recognize the pattern. The sum of two angles, if you're taking the tangent of the sum of two angles, it's tangent alpha plus tangent of beta divided by 1 minus tangent of alpha tangent of beta. Now, I will tell you this. These particular identities, there are derivations of where they come from. I mean, it's not just that they inherently equal each other, but the proving these identities is a little lengthy. So these ones in particular, it is best if you just straight up memorize them. In the next section, 7.3, we have 6 or 7 more identities. Those, however, the derivations are really simple. So rather than memorizing those, they actually stem from these. The next 6 or 7 identities come from these directly. So if you can memorize these pretty easily, the rest of the identities in this chapter are easy to derive from these.
I have a question.
Yes?
For the sine ones, does it matter that it's sine, cosine, cosine, sine? Or does it just like sine, cosine, cosine?
Well, for the sum one, I guess not. If you're adding, because the addition was commutative. This one, you've got to be careful when you switch the order, because the minus sign has to still go with this.
Well, no, I mean like when you multiply them out and then two functions. Like, does it really matter?
Oh, with the multiplication?
Yeah.
No.
Okay.
It's just.
So it was just really bothering me that it was sine, cosine,
Oh, no, not no. All right, last one. Tangent of alpha minus beta. If you're a good pattern recognizer, it's almost exactly the same as this. What do you think the difference is going to be? It's going to be a minus on top and a plus on the bottom. So it's tangent of alpha minus tangent of beta divided by 1 plus tangent of alpha tangent of beta. These are the 6 sum and difference identities. And again, These identities are mostly going to be used for this objective right here, for evaluating trig expressions. We'll do a few verifying of identities, but we're mostly going to stay in objective 1. So here we go. Matter of fact, before I do example 1, let's just do a quick review to make sure we can still do something here. If I asked you to evaluate this is just practice. This is not part of the lesson. Evaluate, I don't know, sine of 60 degrees. Could you do that? By hand, not with a calculator. Sine of 60 degrees. How would we do that? Probably triangle, unless you had your unit circle out, but right triangle.
That's correct.
It's a crappy triangle. Let me redraw this. There. Ooh, that's better. Let's put the 30 degrees up here. 60 degrees down here. 1, 2, square root of 3. So what's the sine of 60? Square root of 3 over 2. Okay. What about, let's get a little tricky here. Let's do cosine of 240. Cosine of 240.
Cosine of 60.
Reference angle?
60.
Reference angle is 60. Okay, so the cosine of 60, we can use this triangle still. Now the cosine of 60 is 1/2, but remember originally we were doing the cosine of 240, so is it 1/2 or is it negative 1/2? Now we have to decide if it's positive or negative. It's negative because 240 is in which quadrant? It's in the third quadrant, and in the third quadrant only the tangent is positive. Okay, so that's just a little bit of prep work. What about this angle then? Sorry, I didn't give you any directions. I just want you to look at this. No, I want you to evaluate. So the problem here, it's not really a problem per se, but the difficulty is that's not a special angle, correct? And since it's in the first quadrant, we really can't use reference angle either. It wouldn't help to use reference angles because we don't need them in the first quadrant. This is where we make use of these identities, okay? These identities that we just learned. Are there two special angles that we can either add or subtract from each other to equal this? What were you saying? 45 plus 30, doesn't that equal 75? So what we're going to have to do is change this into the sine of 45 degrees plus 30 degrees, and now we apply the correct identity to evaluate this. So what was the pattern for sine? Sine, cosine? Cosine, sine. So it's sine 45, cosine 30. Now, is it plus or minus? Yep. Plus cosine 45, sine 30. The nice thing about this is each of these are special angles now. 45 degrees and 30 degrees are special angles. It is not that much work. Sine of 45 degrees is the square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. And then the sine of 30 is 1/2. Now remember, we're multiplying these two expressions here, and we're multiplying these two expressions here. And then we add those two together once we're done with them. So, how do we multiply these two fractions? You just multiply them, right? Just coax them gently. Say, multiply, please. You multiply straight across. Square root of 6 over 4. Plus square root of 2 over 4. would like you to combine this into one term rather than two terms. So this is going to be the square root of 6 plus the square root of 2 all over 4. Now, your calculator can help you to a certain extent. Let me show you what I'm talking about. Unless you have a cheater calculator like a Casio. Does anybody have a Casio in here? No Casios? Casios will tell you the exact answer. But if you're in degree mode, let me make sure I'm in degree mode. If you type in the sine of 75, it'll tell you that nasty decimal, 0.9659. Not really useful. This is not an answer I would accept on a test for any kind of credit. Okay? But you can at least check this now. If I type this into my calculator and hit enter, what would I expect to find? 0.9659. So I'm going to type in square root of 6 plus square root of 2, and then divide that by 4, and I'm expecting to find the exact same decimal. Hey, look at that! So your calculator can help you verify that you have the correct answer at least. Unless you have a Casio. If you type in sine of 75 degrees, it'll tell you it's square root of 6 plus square root of 2 all over 4. Anyway, so let's keep going with this. Part B. Let's do cosine of pi 12ths. Well, the answer is just going to be in numerical values, neither radians nor degrees. You don't have to stay in radians. It's the same idea. We have to either add two angles or subtract two angles from each other to equal pi 12ths. Do we want to stay in radians or should we change it to degrees? It's up to you guys. Degrees? That's fine. It really doesn't matter. So let's change it to degrees. Pi 12ths in degree mode. Pi 12ths. It's probably a really small angle. 15? Let's see, pi. What's the conversion factor? Okay, so pi's cancel. 180 divided by 12. So now we have to consider the cosine of 15 degrees. What two angles could we either add or... Now, keep in mind, it can't just be any random angles like 10 and 5. We can't add... I mean, we could add 10 and 5, but you want to try to do special angles. Ooh. Which one is it? Is it 60 minus 45? Or is it 45 minus 30? It actually doesn't matter. Doesn't matter. Let's do the first one since that was the first one mentioned. 60 minus 45. What's the pattern for cosine? Cosine? It's cosine, cosine, and in this case it's plus sine 60, sine 45. That's the pattern for the sum or difference of cosine. It's cosine, cosine, sine, sine. So, let's evaluate here. Cosine 60. What's cosine 60? Cosine 45. Square 2 over 2. Probably a lot of these answers look pretty similar. Sine of 60 is the square root of 3 over 2. Sine of 45 is the square root of 2 over 2. Well, look at this. Isn't that weird? And just to verify, I would always use the calculator to check the work. Cosine of 15 degrees is 0.9659, so that's square root of 2 plus square root of 6 all over 4. Not this exact same answer, but they're going to look mostly like this form. All right, let's go backwards a little bit here. Let's try example 2. We're going to use the identity in reverse, you guys, just so you understand what I'm talking about. Everybody look up here at the screen for a second. You're going to have an expression that's already been expanded like this, but the problem is these angles aren't going to be special angles. So the intent is to use the identity in reverse and go from here to here. Does that make sense? And then either add or subtract 2 angles, and that'll turn it into a special angle. Here's what I'm talking about. Example 2. Evaluate. Sine 20 cosine 40 plus cosine 20 sine 40. Now individually none of those are special angles, so you can't evaluate them by hand, but if you recognize the pattern that's happening here, sine cosine, cosine sine, what's that the pattern for? The sine identity, and which one in particular? The plus one. So if you apply the identity, this is going to be the sine of 20 plus 40. Which is nothing more than the sine of 60. That's pretty easy to evaluate. Square through 02. So you have a couple like that. Okay. This is actually more what I would like you to expect to see on an exam from this section in particular. These kinds of questions right here. Okay. Evaluate. Given sine of alpha is equal to 12/13 with alpha is in quadrant 2. And given tangent of beta is equal to 3/4 with beta in quadrant 3. So this is your given information. Here's what I want you to find or evaluate. Find sine of alpha plus beta. Thoughts, ideas, concerns, comments? Okay, let's talk about that. Using the inverse would help us find the actual measures of alpha and beta. So we could do that. We certainly could. Keep in mind, though, what section is this coming from? 7.2, right? What have we just learned in 7.2? The sum and difference identities. So sine of alpha plus beta, that's one of those sum identities. What could we do with that? We could expand it into its alternate form. Sine alpha cosine beta plus cosine alpha sine theta. Now, let's take an inventory of what we know, what we don't know. Do we know the sine of alpha? We do. What else do we know? Do we know the cosine of beta? Nope. Do we know the cosine of alpha? Or the sine of beta? All right, we don't know a lot of this stuff here. So we have to now consider, why would we be given this information? Sometimes we're given information that's not very useful, but in these particular problems we're given some pretty useful information. Let's focus on this first piece of information right here. Knowing that the sine of alpha is 12 over 13. We need to find the cosine of alpha. So how does it help to know that the sine of alpha is 12/13? Okay, keep going. Explain. Very good. You're absolutely right. If the sine of alpha is equal to 12/13, so you guys pay attention to this. What's the definition of sine according to right triangle trigonometry? Sine is opposite over hypotenuse. We already know two sides of a right triangle now. We know that the opposite side is 12, the hypotenuse is 13. We can use Pythagorean Theorem to help find that adjacent side. And if it helps, you can even draw a random right triangle if you like to try to visualize these. Put alpha. That means the opposite side is 12. The hypotenuse is 13. What does that make that adjacent side? Obviously, this triangle isn't drawn according to scale and doesn't matter. You can still use Pythagorean Theorem. Try it. Let's have you guys try it. This is stuff you're going to have to do on your own. Don't wait for somebody else to do it for you and then just write the answer down. Try the Pythagorean. That's easy stuff. That's 7th grade, 8th grade math. You can do that. Use Pythagorean Theorem to find that missing side. You got 5? Anybody else? 5? You got 5? You got 5? Okay, I agree with you. This side of the triangle is 5. But I don't agree with the statement that the cosine of alpha is equal to 5/13. I don't agree with that. Why? Why don't I agree with that? I'm not an agreeable person, usually. But no, that actually is incorrect. The cosine of alpha is not 5/13. Can anybody tell me why? We're missing a huge piece of information. That thing that I've circled in red, the sine of alpha is 12/13 with alpha in the second quadrant. That's important. What's the big deal with the second quadrant? Only the sine is positive. The cosine has to be negative. Now I agree with that statement. The cosine of alpha is negative 5/13. You see, I can be agreeable. So now we know cosine of alpha. We're getting there. Let's use the other piece of information, that the tangent of beta. Do the same thing. Exactly. If the tangent of beta is equal to 3/4, what's the definition of tangent on a right triangle? Opposite over adjacent. So do the same thing. Draw a right triangle and just put beta in one of the angles. That means the opposite side has to be 3. The adjacent side has to be 4. And this is just a 3, 4, 5 right triangle. It's a Pythagorean triple. I don't know if I've mentioned this before, but it does help to have a few of these Pythagorean triples memorized, like 3, 4, 5, or 5, 12, 13, or 7, 24, 25. There's a couple of Pythagorean triples that are nice to have memorized. Anyway, so the hypotenuse there is 5. Now, we have to be careful. Beta is in quadrant 3. So yeah, the tangent's positive, that's true, but the sine and the cosine.
I know pattern to it.
Yeah. So what's the sine of beta? Oh, careful. There you go, negative 3/5, because we're in the third quadrant. What about the cosine of beta? Negative 4/5. So let's just do a quick little check. We know the cosine of beta now, and we know the sine of beta. We know everything. Let's fill it in. So let's see. We already knew the sine of alpha. It was 12/13. What was the cosine of beta? Negative 4/5. Now the cosine, we found that somewhere. Cosine alpha, there you are, negative 5/13. And then sine of beta. Negative 3/5. Oh, and this couldn't be any easier. We already have common denominators once we multiply these all out. So this is going to be negative 48. Oh boy. Let's see. 60, 75? 65. And then negative 5 times negative, that's 15 over 65. Final answer here. Negative 33 over 65. Now, I know usually the last thing on your mind during a test sometimes is to check your answers, but with such a long, involved problem, there could have been, I mean, there's a huge potential for small mistakes that could have given you a wrong answer. So let's talk about a way that you can use your calculator to at least check your work. Your calculator won't solve this for you, but it can at least help you check your answers in a way. And we're going to go back to what Maddie suggested at the beginning. We could actually find the measures of, or the actual angle measures for alpha and beta, couldn't we? For example, if the sine of alpha is 12/13, what is alpha? Inverse sine of 12/13. So if you punch in the inverse sine, 12/13. Now we've got to be careful on how we interpret this answer. Take a look at this angle measure, 67 degrees. What's the problem with that? Well, I'm not talking about the decimal. Where does alpha have to be? In quadrant 2. So this is the reference angle for the angle that's in quadrant 2. So how do we actually find alpha? If this is the reference angle for the actual angle.
Subtract that from 180.
We have to subtract this from 180, yeah. So I'm going to type in 180 minus, instead of rounding is dangerous because that's going to make your final answer even more off. So I'm just going to type in that whole answer. 180 minus that is 112. 6198649, that's probably even rounded a little bit. So that's 112.61986. That's alpha. Now for beta, we can do the same thing. If tangent of beta is 3/4, we can do inverse tangent. But again, this is only the reference angle for the angle that's in the third quadrant. So if this is the reference angle, how do we actually find the angle in the third quadrant? We add this to 180. So 180 plus that. So it's 216.8698. 0.8, what was it, 8698 something? So the actual question was asking for the sine of alpha plus beta. So now you could type in the sine of that answer, 216, plus, let's see if I can copy this answer here. Cool. So it's negative 0.507, 6923084. What should we now check? Now, you have to keep in mind there needs to be a small room for error because some of these answers were probably rounded, so we might not be exactly on. Let's just double check. Negative 33 divided by 65. Ooh, keep your fingers crossed. Doesn't this seem reasonable? Isn't negative 33 divided by 65 roughly what? Isn't it roughly negative 1/2? And this is pretty close to that. So, ooh, pretty dang close. So, anyway, you can use your technology to help you check the correctness of your answer. But it actually won't give you the correct answer. You have to do these by hand. Have to do it by hand. If you don't have hands, you got to do it by foot, but it can't be done with a calculator. Got to do it with your feet. Here, try this one on your own. Here's part B. Give you a minute to work on this one. So, it'll be pretty similar. Given given the tangent of alpha is 4/3, alpha is in quadrant 3. Oh, mama. All right. Roll with it, you guys. Roll with it. Sine of beta is equal to negative square root of 10 over 10. And beta is in quadrant 4. You are supposed to find or evaluate the sine of alpha minus beta. Well, let's start with the alpha angle. If tangent of alpha is equal to 4/3. Let's first figure out what we need to find. Actually, before we do this, let's expand this using the correct identity. Sine alpha minus beta is equal to sine alpha cosine beta minus cosine alpha sine beta. So let's make sure that we don't do any unnecessary work. Which alpha functions are we supposed to find? Or which trig functions involving angle alpha? Sine and cosine. We need the sine of alpha here, which we don't have, and we need the cosine of alpha here, which we don't have. So let's find both of them. If we make a right triangle with alpha there, that means the opposite side is 4, the adjacent side is 3. Hey, another 3, 4, 5 right triangle. So then cosine of alpha and sine of alpha can now be easily found from this nicely drawn right triangle here. What's cosine of alpha?
Negative.
It has to be negative 3/5. Because it's in the third quadrant, right? The sine is negative 4/5. Negative also because alpha is in quadrant 3, and both the cosine and sine are negative in quadrant 3. All right, let's do the more fun part here, sine of beta. If the sine of beta is equal to negative square root of 10 over 10. Yikes! Well, we already know sine of beta, so what's the only thing we need to find here? we just need to find the cosine of beta. So let's make another triangle. Now we can put beta here. Opposite is negative square root of 10. Hypotenuse is positive 10.
Don't you drop the negative? Yeah.
Technically we can. I mean, it's not going to make a huge difference because when you square it, it becomes positive anyway. So if we want to drop it, we can do that. Now you got to be careful when we're using Pythagorean theorem. We're finding this missing side, which is not the hypotenuse. So it can't be C. It can be either A or B. It doesn't really matter which one you call it. I'm going to call it B, because I like that letter today for some reason. So square root of 10 squared plus B squared equals 10 squared. So this is 10 plus B squared equals 100. B squared then equals 90. So B is equal to true square root of 90. But we need to simplify that to 3 root 10. So the sine of beta, sorry, the cosine, let's get this right. The cosine of beta is 3 squares of 10 over 10. Now let's be careful to be sure whether it's positive or negative. Beta is in quadrant 4. And in quadrant 4, cosine is indeed positive, so we can just leave it how it is. We don't need to make it negative. So I believe, if I'm not mistaken, and I never am, that we have everything we need. Sine of alpha is negative 4/5. Cosine of beta is 3 root 10. Obviously, I'm kidding. I'm wrong all the time. Just ask my wife. She'll tell you. Cosine of alpha is negative 3/5. Sine of what?
You're married?
Sine of beta is negative root 10 over 10. All right, let's multiply this bad boy here. We get negative 12 squares of 10 over 50. Holy cow, there's a lot of minus signs here. Let's decide right now what we have. We have a negative times a negative times a negative. So it's going to be minus 3 root 10 over 50. Woo! Exactly, negative 15 square roots of 10. All over 50. But wait, we're not done. Simplify that fraction. Let's see, say that again. Yep. Divide everything by 5, and you get negative 3 square roots of 10. Holy smokes. Well, if that didn't just brighten your day, I don't know what will. Let's go on to objective 2, verifying identity. That was all objective 1. Let's just do a few of these and we'll be done. Verify the identities. Matter of fact, I'm going to pause this. All right, gentlemen, Relief Society is over. There we go.
True.
No, it's not. They do a lot of good.
I hate it when they make us go in there.
You are Mrs. Bad Attitude.
I'm just saying.
It's just like, it took a while.
Yeah, because like, we eat waffles. They don't.
Example 4. This will be the final example.
Not something. Oh.
One plus. Holy cow. Kazuna. No, this is going to involve one of these sum or difference identities. I was reading in a Discovery mag, my 6-year-old, she brought home a Discovery magazine from elementary school, and it was really interesting. I was reading through it. A lot of cool stuff in there. But anyway, when you sneeze, you emit over 40 million particles. That was in there.
The National Geographic.
Is that on average or just one person that they tested?
It's probably on average. But that was just for a single sneeze. For you multiple sneezers out there, that's a lot of stuff floating around. I'm a multiple sneezer. I never sneeze just once. So, let's verify. Well, you have to know who the multiple sneezers are, because if you say Gesundheit after the first sneeze, and then they sneeze again, what do you say, Gesundheit one more time? Or, I mean, you're in an awkward situation there.
You just keep going. If they keep going with the sneezing.
No, you have to know who the multiple sneezers are so you can let them finish their sequence and then say
No,
Gesundheit.
but then they have like all these sneezes.
Sneezing sequence.
And then they have all these sneezes unaccounted for. Like,
You bless them for all the sneezes.
no.
Anyway, which side do we want to start with?
All right.
Keep in mind what section this is coming from, guys. What section are we doing here? Sum or difference identities. Does any of these sides look like we might be able to use one of those identities? Doesn't the right side kind of look like it? So maybe we should start there. Let's do the right side. Tangent. See, look, his attitude's improving. Tangent of pi fourths plus x. Let's apply the correct identity. The tangent of, now consider these to be angle measures. If you want to imagine that's alpha and that's beta, then apply the correct identity. These tangent ones are a little tricky to remember. The sine and cosine ones aren't so bad, but the tangent ones still have a pattern at least. You remember what the pattern was? Tangent plus tangent divided by 1 minus tangent tangent. All right, so it's tangent of pi fourths plus tangent of x over 1 minus tangent of pi fourths tangent of x, and we're pretty much done actually. Well, almost done. What is the tangent of pi fourths? Well, what is pi fourths first of all? It's 45 degrees. Now, I know you maybe some of you still have it, but on the unit circle, if you can imagine this, 45 degrees, aren't the x and y value at 45 degrees exactly the same? They're both square root 2 over 2. Now, the definition of tangent on the unit circle is y divided by x, correct? And if y and x are the same thing at 45 degrees, then what's the tangent of pi fourths? 1. So this changes into 1 plus tangent of x divided by 1. Keep going. 1 minus 1 times tangent of x, which is just 1 minus
Wait, where did you get this?
the tangent of pi fourths. Pi fourths is just 45 degrees. And at 45 degrees, y and x are the same. So y divided by x is going to be 1. So tangent of pi fourths turned into 1. Tangent of pi fourths here turned into 1. And that proves the identity. Possibly. But it proves the identity. So, that's it for 7-2.